we were putting it like I was doing the insertion. And it was the last one. I was like, I was really like, this is going really well. And then the registrar was like, she put this one user and sound into users, and it's meant to go to maximum users. And so it just keeps going to like 13, 14. And she's like, oh, that's weird.
All right, I'll just bring everyone in.
Okay. So it could be batteries if you're tiring this.
Well, you know, because there was only up there for the second replacement of not there.
Yeah, I know, yeah. It might have been miles. I didn't get it.
Well, I think, yeah, it might have already been school, so
Yeah, so student community is sad missed his chance to fight for CDH. Nice. Here he always gets rowdy and yelling at people.
you're not that simple.
Yeah.
Oh, I left placement a bit better. I actually went for a run. It was great. We'll get it next year. You'll realize you're not very funny. Yes.
Please start this.
I actually
All right, everyone, we might make a start. Thank you all for coming today, and welcome to our Literature Review Forum for 2017. I think we'll get right into it. First of all, we have Dr. Megan Wallace to give her presentation on tips on how to do the lit review and the oral presentation. So make her welcome.
Great, thanks, Dinesh. So first of all, you know your dates are coming up pretty quickly. I'm sure you're all pretty aware of that. So I think your progress report is due next week. Now, given that next week's also Easter, some of you supervisors might be planning to take some extra time off. So just make sure that you speak to them in advance if you haven't already nailed down a time to go through your progress report. If possible, try and merge those different pages, scan those pages, and then attach them all as a single document. That makes our lives enormously easier. But use it as it's a really good opportunity to have a really honest conversation with your supervisor. To hopefully they will let you know how they think you're going. Often, I think at this stage, students are sometimes feeling a little bit unsure and insecure, and the supervisors will often provide a lot of reassuring advice at that time. And particularly, I think those students who are doing a fundamental science project at this stage, or probably up until now, are often going, oh my God, why did I decide to do fundamental science? This is so much harder than I expected. So, you know, use it as an opportunity to have an honest conversation with your supervisor. Use it as an opportunity to let them know how you're feeling as well. You know, we're used to students saying that they're insecure and they feel like they don't necessarily know everything, and or it might be that you say, can we meet more regularly? I'd really like to meet more regularly. I'm really struggling with this particular concept. So use it as a time to have a really good, honest conversation. Okay, so your literature review is due, I think, in 4 weeks. Yeah. Okay. So coming around fairly quickly as well. Okay, the most fundamental thing is to know that deadline. Exactly, because your supervisor isn't going to remember it. You need to remember it. Yep, and make sure that you get drafts of the literature to them well in advance so that they can read. Hopefully you've already started shooting parts of your literature to your supervisor to read. Look at the marking criteria. Yep, that's what you're going to get marked on. So read that rubric and look at the response sheet that they're going to fill in and make sure that you're addressing the criteria that you're going to be marked on. And be prepared well in advance. It takes so much longer than you expect, I think, writing the literature review. And the revisions particularly, if you've got a supervisor gives you, apparently there are some supervisors who don't read these things at all, a literature review and thesis. I'd probably like to hear get a confidential email if that's happening, if supervisors don't read any drafts at all. Perhaps not if you only send it to them the night before it's due, that might be fair enough. But otherwise, hopefully your supervisors will give you feedback on at least one good draft, and with any luck on two drafts of the thesis, of the lit review. Okay, so it takes time to give good feedback. Takes a lot of time. So really, I can't, say that enough times. Give your supervisor time to read drafts of the literature review. And I know lots of you are perfectionists. You don't like to send it till it's all perfect, but we're going to tear it to shreds anyway. So don't worry about that. Yeah, it will likely come back with lots and lots of either scribbles on a hand drawing, on a printed copy, or track changes on an electronic copy. So don't agonise over particular sections. If you're really struggling with a section, just put a comment in there. I really can't feel like I'm getting this section right, and your supervisors will help you. Discuss timing with your supervisor if you haven't already nailed down time, particularly, this year was really terrible timing with Easter and Anzac Day and school holidays, all really close together with your deadlines. So make sure that you know whether or not they're going to be around and whether they're going to be happy to read drafts while they're on annual leave, if they're going away. And test your conversion to a PDF. Okay, so images just like to fly around documents all over the place. Incredibly frustrating, happens a lot. Make sure you've tested that conversion to a PDF before longer than 5 minutes before the deadline. Yeah. Sometimes, particularly if you've got a Mac, they're often not very good at shrinking your PDFs, so sometimes the PDFs end up massive. There's lots of really cheap apps that you can buy to help reduce the PDF size. Anybody writing a systematic review for the literature review? Yeah, just one? Couple? Okay, so if you do, hopefully you've seen the resources on Moodle on how to write a systematic review. One of the things to be really conscious about is reading those instructions, the marking guidelines, and make sure that your systematic review has to lead logically into your aims, hypothesis, and proposed research methodology. So really make sure that that's very clear. It might be that your systematic review is only covering a portion of the background literature review, so you might need to add some additional information beforehand and additional information afterwards to make that a logical story up to your aim and literature review, aim and hypothesis or research question. I'm just going to talk about a standard literature review today, not the systematic reviews. Remember, we're pretty tough on extensions. The faculty has been audited on special consideration, and we are really strict. If you've been sick for a few days before the deadline, that is not enough for an extension. It needs to be really serious, hospitalised, either you or a family member or partner perhaps hospitalised, something really serious in order to get an extension. Billy, if you haven't already done so, or if there's sections that are missing in your literature review so far, just leave them as dot points as the headings and make sure you discuss that with your supervisor. You'll probably find, if they're anything like me, I'll go, oh, yep, that dot point outline looks great. And then Shag will attest, you send a draft, like, oh no, move that, put that section up there, and that one down there, and that one up there. You know, we'll do that. And then the next time you send it, I'll go, oh no, move it back the way it was. You know, it just depends on the flow on those linking sections, okay? So that's pretty normal. When we send drafts of things to each other to read, drafts of papers, we do the same to each other. That's normal. And give yourself a timeline, particularly if there's only 4 weeks left now. Make sure that you absolutely have a plan of what you're going to achieve in each of those 4 weeks and exactly when you're going to get those drafts to your supervisor. Okay, so your literature review organisation. I always talk about the literature review as taking somebody by the hand and leading them along a garden path. So they need to know right from the outset where you're going to take them, and you're going to guide them every step along that path. Okay, it's really important. You start at the absolute basic fundamental concepts that the assessor needs to read. You don't assume background knowledge. You can assume that the person reading it is going to be relatively intelligent. They'll either have a science or a medical background, but one of them certainly is unlikely to be an expert in the field. So you really need to take that into account and start from the absolute fundamental concepts and then gradually build to the more complex areas. And it should be absolutely obvious what your aim and hypothesis are going to be before you get there. It should actually be obvious from the very first paragraph of the literature review. Language needs to be accessible for non-experts and use figures to highlight important concepts. Figures really are worth 1,000 words. They really are, particularly if one of your assessors is not an expert in the field. Headings and subheadings, can't say how important these are, because often you'll get distracted. You know, it's pretty rare that you actually get to read a document from start to finish without getting interrupted. So at some stage, it's likely your supervisor, the examiners, will put it down and come back to it later. So it's really much easier for them to find where they're up to and recall what they've read so far if they can just quickly flick through those headings and subheadings. Provide clear links. So the last sentence of each paragraph should really provide a logical link to the next paragraph or to the next section. Make sure you keep it relevant, focused and concise. So later I'll talk about the word limit. Lots of students will go like, oh, I have to get it exactly 7,500 words. I can tell you as an examiner, we'd far prefer that it was less than 7,500 words. Yeah, we'd far prefer to read something that's really concise and good than something that's just voluminous words. So this is generally how we think about the structure of any literature review. We put it in this sort of inverse triangle. We start here with really broad concepts, and gradually, as we walk along the path, we narrow the focus of the literature review. So it really should be starting from big, wide, fundamental concepts and gradually narrowing down to the specific area of your research project. So this introductory paragraph, I'll show you in a minute, should actually, that one paragraph should contain each of the major points that the assessor will need to know in order to understand your aim and hypothesis. So you'll have about 6 sentences usually, and that will basically be the major headings of your literature review, and already they will know what the aim of the project is going to be. You start with, and now you see I've got some arrows here. These aren't always in, this is a broad sort of concept of how the structure will look. You often start with the description and scale of the clinical problem and the broad background to the area. Then you start to narrow it down from that broad field to a specific area. You talk about, now you're starting to get down to more detail. So you're talking about what's known and not known. You might talk about the potential causes and then outline the evidence for your particular project. Yep, what's the evidence that suggests that your aim and hypothesis are a reasonable aim and hypothesis? And then, of course, finish down here. Now, as you'll see probably in the example that I'm going to show you, we don't always do it in, so some of these areas we might swap the order so that we've got a logical, just if the links are easier to make. So this is not set in stone way to write a literature review, but generally this tailoring it down, narrowing in an inverted triangle is the way that most literature reviews work. So this is an introductory paragraph. I'll just give you of a student from quite a few years ago now. I'll just give you a minute to read that. So, and from this paragraph, you should be able to essentially tell what the aim of the project, what the aim of his honours project was. Yep, so what do you think the aim was going to be? Yeah, that's right. To look at one potential mechanism that might contribute to bronchopulmonary dysplasia, and in particular, this protein called connective tissue growth factor. Yep, so it's not word for word the aim, but it's broadly, the assessor immediately knows, okay, we're talking about premature babies, we're talking about a disease called bronchopulmonary dysplasia, we're talking about a potential mechanism, ventilation-induced lung injury, and now we're talking about a potential mediator of ventilation-induced lung injury. So it's a really logical, they already know what the end of the path is going to look like. So how does that relate to the inverse triangle? So you can see that the clinical problem has been raised here. The broad background, so the start of, if I have a student who's writing a project in this broad area, they will nearly always start off by talking about the stages of lung development, the 5 basic stages of mammalian lung development. Now we're starting to talk about potential causes, assisted ventilation and lung injury. So what's known? Now we're talking about what's not known. We're talking about potential causes or mechanisms. What's the evidence to suggest that these factors might be involved, and what's the hypothesis and aim going to be? Yeah? So you can see it didn't follow the exact order that I had before, but essentially all those elements are there. And then often it's a good also to bring it back out to the big picture again in your final sentence. So what's the ultimate, what's the big picture reason that I'm doing this project for? Okay, so basically, and as you, that very first paragraph that you put up there essentially gives you the major headings of the literature review. Yep, they were the most important things that you need to get across to your assessor in order to understand the literature review. So immediately, just in that first paragraph, you can tell what the main headings were going to be. Now that triangle reverses when you're talking about the degree of detail. So you started with the big picture and you narrowed it down to a specific topic, but the amount of detail in each of those areas increases as you narrow it down. So the detail, the greatest detail that you'll have are in these final sections of the thesis. That's where you're quoting all individual research articles, and you might go into much more detail about the methodology that they happen to use to really support what the evidence is for and against your particular aim. Okay, so as you progress down that inverted triangle, you get more and more detail. in each of those sections. Just a few fundamentals. Try not to use too many abbreviations. You've probably already, as you've gone around rotations in the hospital, learnt that the same acronym doesn't always mean the same thing when you're in a different unit. So that can be really confusing. So I give lectures on gut development and I talk about AECs, which are apical endocytic complexes, and I talk about alveolar epithelial cells in the lungs. It's the same acronym. They're both AECs. So, but I'm primarily a lung person. So if I see AEC, I'm always going to think somebody's talking about an alveolar epithelial cell. Yep, so remember that your assessors might be from a completely different field, particularly if you're writing anybody doing a really hardcore signal transduction project, cancer biology or, yeah. So you're going to have thousands of acronyms, but it might go to an assessor who isn't used to understanding signal transduction pathways. So you really use figures and diagrams to your advantage there, and only use the acronym if you really need it. You should only need to use an acronym if you're using it more than about 5 times. If you're only mentioning it once, don't bother putting in the acronym. Put a list, it always helps your assessor if you put a list of abbreviations in the front. Most of the types of research that you guys are going don't use footnotes. If there's people doing bioethics projects, it's more standard to use footnotes in that field. But most of the fundamental science or clinical project don't require footnotes. You might want to include a glossary. I think it's pretty rare that students do that, but sometimes they do. Now, as a scientist, we read every sentence. You probably already have realised from some of your supervisors, we can be total grammar Nazis, we can get really stuck on sentences. Do you really mean to say this? And you go, well, of course I didn't mean to say that. I didn't say that. And then when you reread the sentence, you realise that it could be interpreted in a different way. Okay, so science, medical research and science is all about being accurate. Yep, so every single sentence has to be absolutely precise about what you're talking about. Avoid these long convoluted sentences. You've lost track about what you were talking about. If your sentence is 4 lines long, it's too long. 3.5 lines is too long. So try to keep it less than 3 lines long for any sentence. Avoid jargon. So one of the typical sorts, if you're doing scientific writing, so you need to use precise scientific words. So, in the Ritchie Centre here, we do a lot of fetal sheep surgeries. And somewhere along the way, we got in the habit of calling the person who peels the surgical items for the surgeons, we got in the habit of calling them the peeler. And every now and again, you read these honours theses that say the peeler does this. Now, to somebody else, it's completely meaningless. Yeah, it's the theatre assistant, okay, or the scrub nurse or something. But be precise. Try to avoid those jargon terminology that don't make sense to anybody else. Avoid ambiguous statements. So read this sentence and tell me what's ambiguous about it. What's ambiguous about that sentence?
It's two very different ones to essentially describe, isn't it?
Yeah, so this sentence here says that study suggests blah, blah, blah. But actually there's 2 studies. Here's one study that showed something and here's another study that showed something. So the next sentence doesn't tell you which of those 2 things you're referring to. This is what I'm talking about, accuracy and preciseness. You really need to clarify. Every sentence needs to be absolutely clear to your assessor exactly what it is that you're trying to tell them. I'm reading drafts of honours theses at the moment as well, of course. So this is an absolutely classic example of things that examiners pick up on. So this sentence, the function of blah, blah, blah is to do this, and then got some other roles. Yeah, now, as an examiner, we go, Well, what are those other roles? Why aren't you telling me what those other roles are? I want to know what those other roles are. I'm going to ask you that. I'm going to mark you down because you didn't tell me what those other roles are. Yeah? If you're giving an oral presentation and you say something like that, immediately that's a red light to somebody to ask you a question. Sometimes you do actually leave on purpose, leave a hole so that somebody will ask you a question, but don't do it. Definitely don't do it in your literature review. It's like a red flag to a bull. Okay, so if you have something like that, sometimes you don't want to list those other roles because there's hardly any evidence or you know, it's a bit distracting, it's taking you off topic. So the way to get around that is to say something like the main functions of that is to do blah, blah, blah. Then you don't need to bother about listing these things that aren't main functions. You've clarified you're only talking about the main functions. Or you might say, to put them off asking you that question, you might say the main functions are this. Several other roles have also been posed, but there's currently limited evidence to support them. And then you just provide a reference. So you've sort of discounted those things. They're minor things. I don't want you to think about those because I want you to keep on track about the area that I'm focused on. Yeah, so there's ways that you can get around. Spell check. Please do a spell check. It's really annoying as an examiner to get something that's full of spelling and grammatical errors. That immediately, we have a separate part, I think, in the assessment sheet about spelling and grammar. But if it's full of spelling and grammar, you'll get marked down in every section, you know, because it's distracting them from the main point of what you're trying to tell them. Not everything gets picked up in your spell check. So presumably most of you aren't working on ancient Greek artifacts, but you might be talking about experimental artifacts. Yeah. So again, just check your spelling. Clarify if you're doing something for, again, those people who work on signal transduction. If you have to talk about genes and proteins as part of your project, then you need to explain things to people who are not familiar with that area. So in most species, we have a particular nomenclature where you use capital letters for the protein and small letters when you're talking about the gene. So the first time you say that, you need to actually spell it out absolutely clearly, or the assessor is going to think that you're making a mistake, you've been completely inconsistent throughout your thesis. Yeah, so if you've got something like that, make it really clear and stick it in your abbreviation list. Track changes. Whose supervisors have given them feedback using track changes so far? Yeah. A few, right? It's a really easy habit to just go, click, accept, 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 accept. Oh my God, they've left a comment. I actually have to think about it. Yeah, don't just blindly accept those track changes. Really think, why have they suggested that change? Was it because it was ambiguous? Was it because the sentence was too long and convoluted? The only way that you will learn how to write scientifically is by really paying attention to what your supervisors have suggested. Now, sometimes it's our little idiosyncrasies. You know, we just have little preferred ways of doing things, but most of the time there'll be a clear reason why they've suggested those changes. There is some online material to help identify common sort of mistakes. Referencing, you often get lots of questions around referencing. Reference, usually in that first paragraph, you wouldn't have any references. It's a broad overview. You're going to provide all the detail later on. So the first paragraph you wouldn't normally reference. Thereafter, you need to reference every specific statement. Okay? Reviews are okay for broad statements. Those first few sections of your literature review, often you're referring to things that have been known for 20, 50 years, and you know, you might not even be able to track down the original papers of who found them. You can just refer to a review article. Try to avoid textbooks. Textbooks are not very up to date. Textbooks are terribly out of date. So try not to refer to textbooks. Far better to refer to a review article. When you get down to the very end, those final parts of the literature review where you're going into much more detail, we won't expect to see any reviews in there. Yeah, because we're really talking about individual studies and the evidence in those individual studies that suggests that your aim and hypothesis are valid. You will be amazed. Again, an easy thing when you're really busy is somebody, they cite another paper that said this, and you believe it. Don't believe that, because you'll be amazed at how many times people miscite other papers. You'll be amazed at how many times people miscite themselves. Yeah, you'll read an abstract and go, fantastic, that supports my hypothesis. Then you go through and you read the methods and you read the results and you go, hang on, they've just said the exact opposite thing in the abstract than they actually have shown in the results. Yeah, it happens. Okay, so you really do need to go back and check the original source of the data. Endnote, is everybody using Endnote or some other program? If you're not, you need to do it right now, really soon, because it takes a long time. Similarly, set up your headings using table of contents as you go along. If you don't know how to do that, I'm sure there's easy YouTube clips or one of the other students will be able to show you. It will save you an enormous amount of time to generate your table of contents at the end, particularly when you have a supervisor like me who makes you change sections around. Okay, don't hide behind discrepancies in the literature. You know, you've come out of medicine where things are black and white. We do this because of this. We do this, we just do this. This is what causes this. Now you're entering the realm of the unknown. Yep, so there will be discrepancies. There will be one study that shows something increases and another study that shows it decreases. You need to highlight that. Don't shy away from showing that some studies show that one thing happens and other studies show that things don't happen, because that's the difference. That's what happens with experimental design. It can have a big impact on the outcomes that you measure. And depending on where you are in that inverted triangle, you might discuss the reasons for those discrepancies. So if you write down here, in the pointy end of the triangle, then you might talk about why it is that that particular paper showed an increase while that other particular paper showed a decrease. Figures. Be really generous with figures. Examiners, we love figures. It helps us understand things, helps us remember things if we're not an expert in the area. If you are using figures then you must reference the original source. And if you're using the figure legend identically from the paper, then you need to have that in quotation marks. Yeah? Otherwise it would be picked up as a Turnitin, as an episode of plagiarism. Okay, so if you take a figure directly from another article, then you state taken from. If you modify a diagram, then you say modified from. Yep, it's okay to modify other people's diagrams. Often they've got 100 extra labels that you don't want to have on the figure. You just want the most relevant diagrams. So this is what a figure should look like in your thesis. It should have a figure number, should have a figure title. Normally we'll put them in bold. For a figure, it's usually underneath the figure, and then there should be a figure legend that explains it in detail. If there are things that aren't labelled, like up the top here, then it should be clear that that's, in this example, is referring to weeks. Yep. So if there's an acronym or something in there, then you need to explain what the acronym is. How many references? People like to know an exact number of references. This is going to vary enormously depending on the field and how much is known in that field. I think if you're doing more than 120 references, you're probably going a little bit overboard. We don't like to read a sentence with 10 references at the end of it. We're normally pretty convinced by 1 or 2. I think most theses will have more than 50, but if you're working in an area that's really new, it might be that hardly anybody has published in that field yet. This year, for the first time, our word limit is hard. 7,500 words, no more. Yeah? So that's because when we as scientists, we don't have the flexibility of plus minus word limits. When we submit an NHMRC research grant for our next 3 or 5 years of funding, we have 9 pages, but 9 pages including references to describe all of our findings, whether it's a 3-year grant or a 5-year grant. Yep, no flexibility. When you submit a small application to a philanthropic funding body, then they'll say 150 words for this section, a maximum of 2,000 words or characters in this section. Yeah, so you need to get used to having very hard limits. So no more than 7,500. That's already a lot of words anyway. The limit excludes fundamental things. The limit excludes cover page and declaration, etc. You can read that in the unit guide. Your headings and your in-text citations are included in the word count. So it's best to use, if you're using Endnote or something, then choose a journal style where it has numbers rather than Wallace, Narula, 2, XYZ, somebody else, you know, that's going to take up a lot of space. Choose one. Numbers is usually the best way to keep your word limit within the right frame. Turnitin, another major change this year. The university has decreed that if you're past second year of university, you will no longer get to see the matches from your Turnitin reports. Okay, so they figured that you've already been through, everybody's seen used Turnitin before? Yep. And you used to be able to submit to Turnitin and then you got to see where the matches were? Yep. So you haven't done that before? Yep. So they figured that by the time you're at third, fourth, fifth year, that you should already know how to write sentences in your own words. Yeah. So the easy way to get around that is never write identically from a journal article. You can have a separate document where you might copy paste sections of text, but in your literature review, don't ever write anything. It goes from that document, everything in your own words in your literature review. There are some things that come up in honours thesis that I see as matches all the time. I'm not worried about. So the table of contents. So if you were doing, most students, honours students in my lab would have a table of contents that the headings and subheadings would be really similar, at least the first half. Okay, so that would come up as a match. That always comes up as a match. I don't care if your table of contents is nearly word for word the same as some other student from your lab. I don't care about that. Definitions. There's only so many ways you can define something without changing the definition. Yeah, so that nearly always comes up with a match with somebody, some piece of text somewhere. If you're defining hypertension, for example, you know, there's only so many different ways that you can write it. So if you want to really, I don't care if I see something that's clearly a definition. I'm not too fussed about a fairly high match rate in that portion. But if you're worried about it, just put it in quotation marks. Take it directly from, you know, whatever the clinical guidelines are, and use that. Put it in quotation marks. Questionnaires. If in your methods part at the end you're attaching a questionnaire, that questionnaire has been used by some other student, of course it's going to be a match. Yeah, I don't care about that. That's logical. If you're using methodology that's identical, a piece of methodology that's identical to somebody else, I'm not too worried about it either. And ethics statements always come up as a high match as well. So this is what I would see in lots of people's literature reviews, a sort of match. Obviously I couldn't take somebody's actual Turnitin match, so I've pretended, using that same paragraph as before, I've pretended the sorts of match. This is a sort of match where it's quite clear that students attempted to write it in their own words. Yeah, I'm not too worried about that. If it looks like this, however, I'm going to be worried. There's whole sentences in there that are word for word, or a sentence where maybe there's only one word that's been changed. So those are the things I don't like to see. So I indicated this at the start. One of your examiners will be nominated by your supervisor. It's likely they'll be an expert in the field. They'll know a lot about the field. The second examiner, we nominate from within the pool of other supervisors. So they're unlikely to be an expert in the field. It might be, by chance, that they happen to know a lot about your particular organ or tissue or disease, but chances are they may not be an expert at all. So you need to take that into account. Remember that lots of the supervisors are scientists, not clinicians. And so you just got to remember to tailor it to your audience, to a broad audience. Okay, and your supervisor, of course, will be asked to examine the literature review from another thesis, the literature review from another student. Okay, and that's usually the same. In 99% of the cases, the two people who examine your literature review will be the two people who examine your final thesis. So pay attention to their comments when they come back. Oral presentation, I'll just really quickly go on oral presentation. So it's 10-minute talk and 5 minutes of questions. That usually means 10 to 15 slides. Again, check the marking guidelines. What are you actually being marked on? Make sure that you know and you've prepared your presentation accordingly. In an oral presentation, we only expect you to reference really important points. You don't need to reference every single sentence there. It's not like your literature review. Less is more. You often have students in a literature review, giving their oral presentation, and they try to get everything in, and they're going through their slides, and they're doing this, and you can't hear them. You don't have time to read the slide. You can't understand what they're saying. So less is always more. Keep your slides really simple. I have failed that in many of the slides in this talk. Every time I've put up a paragraph like something like this, I mean, you would never normally put up something like that in an oral presentation because you just can't. You wouldn't expect your audience to read it. Again, you should be taking the audience by the hand. It should be a really simple, easy story across only 10 or 15 slides to explain where the basic fundamentals, what's the big clinical problem that you're addressing, and then what's taking them to your aim and hypothesis. So keep it really simple. Try not to read. Yep. Try not to read from notes. Much better. If you're a really nervous speaker and you like that security of having notes, just try and have logical prompts on your slide. That's usually all you need. But the prompts need to be meaningful to the audience as well, not just to you. So the word prompt on its own is meaningless, but if you have used prompts as guides, then it makes sense to the audience. Yeah. And good links, again, really important. The final sentence of each slide should logically take you to the next slide. Diagrams help. Shag's going to recognise this one, particularly when you get to your methodology. Timelines and experimental interventions really helps if you include detail. We generally break it up into about 60% background and about 40% your proposed methodology. Really important if you're doing stats that you mention the stats that you're going to use. And try to finish with an expected outcome slide. So bring it back out. What's the big picture question? What's the reason that you're doing this study for? And prepare backup slides. We don't need a slide with references on. Don't bother doing that. Common mistakes. These are the sort of really common mistakes I get when I'm really nervous and talk really fast and nobody can understand me. That's the most common. So when you come up to the stand away from the little microscope for a minute and just take a big breath and relax. Yeah? Slow your heartbeat. The other thing is that people are really nervous and they speak really quietly and then they can't hear. Yeah? So you need to use volume. Use the volume, speak slowly, speak clearly. Try not to speak, try to get some intonation. You'll see some people, I'm a probably excessive intonation in the way that I speak. I'm certainly an excessive hand user. That can be quite distracting. If I was giving a formal presentation, if I wasn't talking to students when I was at a conference, giving a formal presentation, I wouldn't be doing this quite as much. I'd be much more serious about my presentation. When pointing, so if you do happen to have a lot of detail on the slide, it can be, or it's a complex slide, it can be really difficult for people to follow. So really take advantage of having a pointer to highlight what it is that you're interested in. It's okay to look away. If you're pointing, you obviously need to look at the slide, but otherwise you should be engaging with the audience. People, if there's a lot of seminars going on in your slide at 7 o'clock at night, just after lunch, everybody's got that postprandial nap thing going on. Look at them in the eye. Yeah? I tell you what, it really, I go, ooh, better pay attention. Okay, so really make sure that you scan the audience and make eye contact with those people, because then they will pay much more attention to your presentation. If they're paying attention to your presentation, they'll understand it and they'll give you a higher mark. Distracting, as I said, distracting, I go like this. Usually that's because I'm giving lectures to students, I'm like trying to keep them awake. But, you know, avoid other distractions. You know, it's fun when you first start playing with PowerPoint, you get all these animations and you can do cool stuff and you can put in really funny things on your slides and you go, that's really cool. But actually, in a scientific presentation, that can be really distracting. One of the probably best examples, I told these guys last year, when I was in the Department of Physiology and we had an honours student who was working on sperm. And he had a slide, and the fundamental background to the slide had a built-in animation. There was a little white thing from here, and it would zoom across the, spread out and zoom across the slide. The moment you flicked to the slide, it looked like every slide was ejaculating. So at every slide, the entire audience was crying. By the end of the presentation, there were tears running down people's faces. They were laughing, and then they go, oh, we've got to concentrate. You could see the laughter would dim, and then somebody would start giggling, and the entire audience would erupt in laughter again. It really was, it's the funniest talk I've ever been to. But nobody heard what he was talking about. You couldn't mark him because we didn't actually know what he was talking about, because we couldn't hear him over the laughter. So just, you know, bear your animations in mind. Use them to your advantage, not to your disadvantage. The other thing is try to speak conversationally. Often if you're nervous, you'll try and rehearse word for word. You know, what you've written down, your pre-prepared thing, you want to keep exactly the time, so I need to say exactly the words I've pre-prepared. That's an absolute major way to completely lose the words that you're looking for when you're giving the presentation. Yes, so try and make it a bit more conversational. We want it to be a conversation with the audience. Also be careful using written terminology. So this is something that makes, we go to Japan twice a year to do experiments, and every year we have to sit through this radiation safety training, and we laugh in it because they use words like, moreover, when you do this. It's like, moreover, nobody ever says that when you're speaking. You might write it, but you never say that when you're speaking. Yeah, so just remember that this is an oral presentation. Use spoken words, not written words. Practice out loud. It can be word perfect in your head when you're saying it silently. It's very different when you need to say it out loud. When it comes to question time is absolutely the hardest part of giving an oral presentation. Absolutely the hardest and most scariest part. You have no idea what they're going to ask. It is okay. When you're a clinician and you want to give confidence to your patients and your fellow clinicians that you're working with, that you know everything. You're confident and you need to exude that confidence. But now you're doing scientists. We're working in the realm of I don't knows. There's lots of things that we don't know. This is when you're really starting to learn about all the I don't knows. So it's okay to say that. If somebody asks you a question, it's okay to say, that's a good question. I don't know. In fact, I'm not sure if anybody knows. Yeah? Or I don't know, I'll look it up. Or do you know? Throw it back to them, because I don't know the answer to that. Do you know the answer to that? Sometimes we ask it out of ignorance. We don't know what the answer is. And sometimes we're testing it. But it's okay, because then they get to spout their knowledge. And they go, oh, I'm pretty good because I know the answer and you don't. Yeah? So I wouldn't do that too much. But usually it's okay. It is absolutely perfectly okay if somebody asks you a question to say, I don't know. It's far better to say, I don't know, than to say something that is wrong. Because if they know the answer, And particularly the first seminar, we're often testing your knowledge when we ask questions in that first seminar. So it's really bad. It is one way to lose a lot of marks if you say something that's wrong, if you just make it up on the spot. Far better to say, I don't know. And prepare backup slides. You can't stick everything. If you've got anything complex in there that you don't have time to explain in detail, then stick in the backup slide. And you click on, here's one I prepared earlier when they ask a question. Okay, it looks really good, looks really professional if you've got pre-prepared slides for some of those questions. You should be able to go through pretty much every single slide in your talk and think of a question that could be asked. Yeah? So really try and think in advance. Talk to your supervisors about what questions you might get asked. You'll only be able to predict a proportion of the questions anyway. Again, there's some online information to help. And the thing I've forgotten to put in there in the literature review, back up, back up, back up, back up, and back up again. Yeah, absolutely. That is absolutely when your files are going to crash. So make sure that you back up everything, back up regularly. You write a great paragraph you've been struggling with for ages, and all of a sudden, oh yes, the words are flying out, fingers are going at the speed of light. Save. Press that and save it, because you'll lose that train of thought in a minute. Okay, any questions? No? Yeah? Yeah, so this is, I mean, we often there might be more than one aim in a project, and that's perfectly okay, as long as they link logically, as long as the background covers it, and usually the one project links logically into the next project. If they're not linked, that's when you come up with problems. If there's no logical link between project one, or the literature review is clearly separated into half about aim 1 and half about aim 2, and the two aims are not linked, then don't do it. Because when it comes to the discussion, you're only going to have half the amount of detail on each of those aims, and you'll get marked down because you haven't gone into enough detail.
So provided that the background sort of covers both of them, while in play, I can still discuss both of them.
Yep. Just label them as hypothesis 1 and aim 1 and hypothesis 2 and aim 2, something like that. Anything else? No? Good. Okay, well, good luck. It's only a few weeks left. I live up on the 5th floor in this building, so, you know, we're emails and phone calls away. It's a pretty stressful time coming up to that last week of your literature review for most people, particularly given that we've got the Easter break and Anzac Day break so soon beforehand. Okay, so good luck, and I'm going to run away, leave you to these two to give you the honest truth. Dinesh? Where's your hidden under there?
Yep, to take out the USB, is it? Or the cursor?
And just close the...
Yep, sure. Hi. No. Do you mind if I just take it out? Thanks so much.
I'll see you later.
Sure thing. All right, guys, we'll continue on. So thanks very much to Dr. Wallace for giving her talk. It's not often that we get a chief examiner to give us information about our assessments, so that was very useful. We'll move on now to the student presentation. So we have two students from who did BMedSc last year to give us their views on the literature review. Our first talker is Jack Tu, and he did a a clinical project. So he'll give us a perspective from the clinical point of view. So make him welcome.
All right. Gotta reposition this. Okay, guys. So thanks for the kind introduction, Dinesh. My name's Jack, and last year I was 12 months ago, I was in your shoes, pretty stressed out about the literature review, but hopefully with some of the advice that Dr. Wallace has given, as well as tonight myself and from Shag, that we'll be able to alleviate some of the stress that's associated with writing it. I should give a quick disclaimer before I talk that all the advice that's contained within these slides is based on my own experiences from doing the BMedSc year, but I have done a quality test and asked a couple of friends also in BMedSc about their tips and tricks from when they did the lit review to validate, but it's a pretty crap sample size of 3 people. But anyway, we'll do our best. Can I get a show of hands of how many people are doing like clinical-based projects? Oh no, so quite a few compared to my year, so that's really showing. So hopefully some of the advice I give can be useful for the clinical projects, but I've also tried to keep it as general as possible. So for the guys doing lab-based projects as well, hopefully there's 1 or 2 points that you can take home from this presentation. And as you know from Dr. Craig Hassad's presentations for pre-clin years about the stress performance curve, and right now during your lit review, you're probably in the red section probably, or very close to it, or in the orange section. So hopefully the talk, we're going to try and push you into the optimal stress area, the yellow section. I'm going to briefly talk about the department oral, since that's one of the assessments that will be coming up for you guys very soon. I think in, was it 3 weeks or something? So pretty close. And the first question you need to ask yourself is, who is your audience? Because that's going to be quite important to know. So for myself doing the clinical project, I was presenting in front of a group of clinicians. So it's really worthwhile putting like a clinical vignette at the start of your presentation. So it shows to your audience, how does your project relate to the clinical setting that they are working in? It gets their interest into what you're talking about for the next 10 minutes. So that's worthwhile. Whereas if you're presenting in front of scientists, you might have to phrase your presentation a little bit differently. And then you also need to think about, what is your key message? What is your take-home message you want, people to get out of your presentation? And often for clinical projects, you're trying to show that there is a research gap, there is limitations in the current literature, and your background should really emphasize and lead down to that point. And then you're going to tell them how your project is going to address that limitation, essentially. And you should also show how that background matches the aims and hypotheses of your proposed project, because there's nothing more distracting to your markers than seeing like, great, you've identified this research gap, but your project doesn't really answer that question, essentially. And that's also something to keep into consideration when you're doing your literature review as well. The next thing to think about with these things, as Dr. Wallace said, is your slide layout. So less text is more when you're doing oral presentations, and clinicians in particular love figures. So doing animated figures is also very worthwhile. Appropriate animation, as Megan said, so graying out text, pointing arrows as you're moving through a figure, or showing parts of a figure that then slowly complete as you go through the slide is also really useful. I've already pointed that out before, and as I said, try and keep to 1 slide per minute for your oral presentation. Think about supplementary slides as well. So the classic question you'll often get asked about for your project is, what is your methodology? So really have a slide on your methodology in your backup slides. You're not going to talk about it in 10 minutes, so have that included. The other thing that my supervisor once told me is like, sometimes you, as Megan said, in the literature review, there's little red flags where you say like others, other functions, and those sort of things. But used appropriately in an oral presentation, you can sort of bait your audience into asking certain questions. Go, well, this is something that I have prepared earlier. So that's probably one setting where it is appropriate, but don't do it in your literature review. The other major tip, so regardless of anything I say today, this is probably the most important tip, is that if you haven't started writing a literature review, start today, tonight, basically. Because basically, I like to think about the literature review and also your thesis in general as a bit of a marathon. Sounds really daunting at the start. The first 5 columns sucks so much, and you're just going like, why am I doing this? Why did I sign up to do the BMedSc? But as you get closer and closer to the end, it gets a bit more easier. So I think that's often the first part to overcome. And given that your due date's in less than 4 weeks, I'd really get onto it. And as Megan said at the very end, back up, back up, back up. So what I did in my year is have a saved version on Dropbox or some cloud service that you might use, have a saved version on 2 different USBs in case things go to crap. And then the version that you're actually working on, like as you're updating and working on every day, keep that on like your desktop computer. And every time you do any major changes, save it across those 3 mediums. So if you run into trouble, like someone steals your computer, Dropbox decides to close down tomorrow, or you lose your USB, you have some form of getting back your lit review. The next thing I'd say is to have a plan. So, having a timeline is really important. And if you haven't already, you should be meeting your supervisor to discuss what that timeline looks like. So something that I did last year was using something known as a Gantt chart. It's basically a fancy timeline. And you sort of group it into various categories. So different assessments that you have to do during BMedSc, things related to your project, so patient recruitment, ethics approval, when you're going to stop recruitment, when you're going to start to do the statistics, any other personal commitments like holidays, or you're going away for some other reason, or there's a wedding on. And then also putting in the dates that your supervisor has told you that they're going to be on leave. So that's really important to have, so it gives your supervisor a clear understanding of when you're going to meet the deadlines and when they can expect for you to submit parts for them to read. Okay. The next slide is to have a structure, of course. So Megan's already highlighted one structure of how to do it, and this is just literally me pulling out from my own literature review. So starting off with, this is a pretty standard structure. Start with background, of course. Your literature should start off broad and become more specific. Chapter 4 is pretty important, so your knowledge gaps are highlighting I guess the limitations of the existing literature. So this is where you raise all those discrepancies and saying like how the current literature is kind of limited and there needs to be more research into that area. And that's where you sort of summarize the conclusion of why your project's so important. And then your appendices should include all the basic preliminary stuff for your project as well. Remembering obviously headings and subheadings. And a really important point as well is to look at some of the examples on Moodle, because these are people that have scored very well for their literature reviews. The other thing that's worthwhile asking is if your supervisor has had previous students, if you can have access to their work. And often those students are more than happy to share their work. So you can see particularly what's the standard that you need to aim for. Because more often than not, your supervisor will pick the same expert examiner in that area as well. The other thing is to ask your supervisor, would they prefer you to send it all at once, which is what my supervisors preferred, or do you want them to be sent in sections? And I think one of the things that is quite daunting with the literature review is you might say, oh, I haven't finished reading all the relevant articles, I'm not ready to start it yet. But if you have your subheadings and headings already ticked off and approved by your supervisor, and as you're reading through all your articles, you can go like, oh, that's a really interesting point. Or, that article is really good for this particular section. So then you put a dot point under that heading, you put the little reference from Endnote, and you can put it word for word then, but then obviously when you're writing the final draft, make sure you paraphrase it, write in your own words, write any comments about this particular study, saying like, oh, it had these limitations, or small sample size, etc., etc. And then those dot points will eventually form paragraphs of each of your sections. So that's one approach you can do with literature review. When you're thinking about looking at articles, of course, you can have a look at who wrote it, when it was published, what was the aims and conclusions of those studies, thinking about the methodology. So does the methodology of that paper actually make sense to answer that particular question? And it's also important to think about the limitations, not only the ones that are specified in the article, but thinking about for your clinical question. So for instance, in my study, a lot of the existing literature is very limited in the ED setting. A lot of these studies were based on inpatient children or children who underwent very invasive testing. So thinking about how the study had limited applicability in the setting of my project was a particularly important point to raise. And then thinking about extracting it, of course. So this is the part where you go making comments about like, oh yeah, it's a great study, a bad study, why not? And these are the points that you raise with your supervisor. If you're a bit unsure about like, what do you think about this article? I'm not too sure. What are the limitations? And this is where you can get great feedback from your supervisors about this. At this point, it's already been discussed at length by Megan, but these are some important points when you're writing your literature review. Think about abbreviations, using them sparingly, but if you're going to use them, use ones that are actually established in the literature. So obviously CRP, most people would understand to be C-reactive protein in the clinical setting. Don't be making up new abbreviations because, yeah, it just confuses everyone essentially. The other thing is obviously sentence length. So if your sentences are going beyond 3 lines on your Word document, split it up, break into 2 sentences essentially. And as Ning said, your storytelling. So your conclusion should answer what your introduction says. It should make sense from that regard. And use clear language as well. So don't use convoluted things like male pediatric patients when you can just simply say boys. Past history is a very redundant phrase because, of course, history is always in the past. So thinking about these sort of terms, just add to your word limit. They make you sound really smart, but then your examiners are very concise, on the point writers, so make sure you don't do that. And the other thing as well is to think about your 50 friends or friends in other year levels. Like your 50 friends are all pretty relaxed right now, apart from being on really long days, but you know, job applications haven't started yet, so it's worthwhile recruiting them to ask them to review your actual literature review, to say, hey, do you mind just reading over the grammar or the spelling on my thing? Does this make sense to you? And then you can say, you'd be nicely acknowledged in my declaration of contributions as well. So yeah, it makes sense. And it's also reassuring as well to go like, wow, I spent like 3 or 4 months writing this like really, really long document. My supervisor, I'm not really sure if they spent enough time reading, make sure the grammar and spelling is right. Hopefully having a 3rd or 4th person read it, they go like, yep, it makes sense to me. I'm not going crazy. So that's really important to think about. And how many of you guys have actually used Endnote or some citation program? Put your hands up if you're using it now. Great. I'm a bit concerned there are a few people who aren't using Endnote yet or some citation program, because there was definitely a couple people in our cohort that did not use Endnote for the whole BMedSc year, and that caused a lot of grief and caused a lot of pain and agony. So please, Endnote is your friend, but you need to make sure you treat them well, because if you don't treat them well, then Endnote will cause you lots of grief and anxiety. And the number 1 tip I must say is that when you're actually writing your document, please make sure that you use it in unformatted citations. So if you go to your tab on Word, Endnote X7, click Convert to Unformatted Citations. The reason why is that if you try to remove a citation when it's auto-formatting and auto-updating when you add a new citation, there's a lot of behind-the-scenes text encoding that's still left over every time you do that. So eventually, if you're like me, you're well into at the end of your literature review, and then it crashes and you go, oh crap. So this is why I recommend this in particular. It also saves you time as well, because every time you add another reference, add another reference, add another reference, you always say it will update the whole document, and it saves you from doing that while you're working. It's so easy, and you won't cause any grief as you're doing the thesis as well. Make sure that your EndNote library is saved to a local drive while you're doing this. Don't use an EndNote library from a cloud service, because that can cause you a lot of trouble as well. And it's really easy to get the actual EndNotes or the reference from your articles. Just go to PubMed, search up the document essentially, and then download it to your citation manager. Very easy. Remember to add and remove references using the add and delete function. So it clears out all the coding that goes behind the scenes. Obviously, when you're sending to your supervisor's review, make sure you convert it to plain text. So you've updated it while being converted to plain text. The reason why is that you don't want to cause your supervisors any grief, because they might do track changes and remove certain references. And if it keeps crashing them while they're doing that, then maybe they get really annoyed and won't actually read your article properly. So you want to cause them as minimal stress as possible. And finally, of course, make sure you check the PDF after you've converted it to that form to make sure things haven't gone willy-nilly and those sorts of things. So that's all the things I had to say today. Good luck with everyone. Good luck with writing your literature review, everyone. And does anyone have any questions at all? Cool. If you have any thoughts, oh yeah. Oh yeah, so I sent them to Nash. Yeah, of course. If you have any other questions in the meantime, or you think about them later, feel free to shoot me an email and I'll try my best to get back to you on a timely basis. Thanks, guys.
Thanks for that, Jack, giving that perspective from your experience. We'll get on to the final talk of the day from Shag, who will talk about her experience from a fundamental science / lab point of view. Just get it. And just at the end, Megan Wallace wanted a big group photo of the cohort, so we'll quickly do that just at the very end before you go, just letting you know. Cool, over to Shag.
Okay, hey guys, I know it's pretty late and we've had a lot of talks and you're quite tired, so we'll get through this quite quickly. So I'm just going to give you a bit of an overview geared to those who are doing a science project. So I did my BMedSc last year. I did it actually with Megan, which is not the reason why I'm here. But and I looked at the trophoblast cell, which is from your embryology days, you might remember, is part of the placenta, and a protein marker called TROP2. And wait, is this recorded?
Yeah.
Okay. It was really hard. So that's just a thing that if you're doing a science BMedSci, like, don't panic. It's a universal experience to feel like an idiot for literally the first 6 months of your BMedSci. And there will be times where you read an article and you're just like, I don't even understand anything other than the abstract. Like, I literally cannot read this article. And that is fine. And it's hard because you've obviously all come from med, where you're very clever cookies, and you sort of, like, you don't know what's relevant. You'll read these articles and you'll think, oh, is this MAPK ERK1 pathway relevant? Or is it like sort of like a maybe one of the theories? And it's quite hard to figure out if it's important or not. And that's where your supervisor comes in. That's when you should have that rapport that you can send them an email and say, what this relevant? Or you can just go and ask them like, hey, I'm really confused. Should I bother getting invested and reading about this? Or should I just like make a note of it and move on? But with regards to the actual lit review, so when you're writing a lit review, you have to think very straightforward, as we've all been talking about tonight. Like, what's the whole point of this? Why am I doing this? And you're pretty much going to be doing 3 things in your lit review. You're going to be summarizing the literature and making a critical appraisal. So have the guts, I guess, to take a stand and say, this is what the evidence suggests, and the evidence is good, or the evidence is bad. Because what a lot of us do is we'll just say, the evidence for this topic is X, Y, and Z. And you will never say, but I reckon Z's not correct because of, you know, that's what makes you a more mature writer, is if you can take a critical appraisal of the research, as opposed to just telling them what the research is. So you want to be summarizing the research. You want to impress the relevance of your topic. You want to hype them up and say, holy shit, like, you know, improper placentation is the end of the world. We need to fix this. And then you need to say, and that's why my project, which is, you know, going to do this sort of mechanism and explore that type of pathway, is really going to help this horrific problem of placentation that everyone cries about at night. And I'm genuinely, like, not trying to like overemphasize it, but you're going to be referencing in 1 or 2 sentences A, B, and C at the end of every section, and pretty much always A and C at the end of each subsection. And you're going to feel like you're reinforcing the same concept too many times, but you need to do that. You need to be constantly reinforcing, because your lit review is pretty complex and fancy, and your reviewer is not paying attention. And that's just sort of like, you just got to keep doing it over and over. And yeah, just check the marking criteria. Megan's very, very sensible. So she writes a marking criteria that she wants examiners to follow to the dot. And if you follow the criteria, you're pretty safe. So when you're doing a science, so whoever's doing a sciencey BMedSci, you might feel a little bit overwhelmed by the number of articles that will have your keywords in them. And that's because a lot of the scientific concepts will overlap. So signaling pathways can be ubiquitous. They can be in like every single part of science. It can be in cancer research and like, gynae research and cardio research. And you might be like, oh God, do I have to read all of these papers? How? I don't even have time to read like 5 with understanding them. But don't panic. Unless you're writing a systematic review, you're not meant to be reading all of them. There are papers that you don't have to read as long as you cover the basic concepts. And your supervisor knows that. They know that you're just going to be covering the relevant bits, and probably not even to the detail that you all deep down think that you need to do. They actually really want quite a superficial sort of amount of detail. Don't spend days reading old content. In science stuff, things change really quickly, especially, articles from 1990s. Let a review article tell you what the old theory was, and spend your time on what the current theory is. And that's really important for word count. no one's going to care if you write a whole paragraph about the previous, existing theory on placentation was blah, blah, blah. But then recently they've discovered, sorry, I ran out of words. I can't tell you what they just discovered. So it sounds really like common sense, but and then there's the rabbit hole. A lot of scientific articles take you down this rabbit hole and you're sort of like, where is this going? It's linking something else. I need to read about that other thing so I can understand article A. And you might just be spending a lot of time on something that's not important. So just check with your supervisor, if you can. Some supervisors aren't around. So this is formatted weirdly, but when you're starting off with your overview, the best people to ask is your supervisor or to read a review article, because that will tell you really where your research ends, so you don't feel like you're wading through this bottomless pit of things to learn. Your supervisor will say, here's the main concepts on this topic, or the review article will say, here are the main points that you need to cover. So just as an example, I looked at placentation, and my background literally included stuff on the menstrual cycle, which seems so basic, but Megan said it was important to provide background. And then I went into each of the things. I went into what a trophoblast cell was, and I went into what the protein was, and I structured it in that way. When you take notes, everyone's been saying this, but you make a subheading, and I think the easiest way of doing it is to have a specific question, and then have a table that says, who was the author, what was the year, and then a different box you can have, was there anything important with the study design? If you're doing a clinical project, you can often, at the start, you'll read a clinical trial and you'll be like, oh, that's dodgy, they didn't include the right people. But sometimes when you're doing a science topic, you'll read an article and you'll be like, look, there's a methodology where I don't understand any of the words. And so it's hard to know if the study is good or if it's bad. So don't worry, just write down what it is and you can go back to it later on, because you might not know at the time if that's actually the right way of sciencing. Does that make sense to you guys who are doing science topics? No one else understands unless you do a science BMedSc and you cry a lot. So, and then with PDFs, I really recommend saving them, because again, you may not know which part of your article is actually going to be important. You can type on them, you can highlight them. And Endnote has a smart groups feature, and that's really good, because if you've got over 100 citations, it's nice to be able to break it up into, oh, that was a reference for this paragraph. So that's quite a handy thing. Just a little bit about sciencey stuff. So no one really teaches you what basic science concepts was. And I remember in my first few weeks of my BMedSc, I actually looked up a molecular biology textbook, because I did not know what hedgehog family was, or what all these variety of integrins and ligands and receptors. I didn't know where it all fit into the big picture of science. And so I made myself a table and I said, these are the common types of concepts I'm going to be talking about. These are adhesion molecules. These are signaling pathways involving these types of things. These are gene cycle regulators. And it kind of helped, because then I could read an article and say, oh, it's talking about this pathway. And I look at my cheat sheet, and my cheat sheet would say this pathway is common to these fields. Do you remember the Bradford Hill criteria that we did in 3rd year or 4th year of ABCP? That's pretty much really common things about causation. And in science, one of those is if X causes Y, then more X will cause more Y, and less X will cause less Y. And that's the way that a lot of scientific study designs are based off, is that sort of principle of, to prove a point, here are the things that you need to do to prove it. So if you're reading a scientific article and it's only doing one, it's only saying that this gene promotes this pathway, but it's not showing you that stopping that gene reduces that pathway, then you know that it's insufficient. It's actually only telling you half of the story. And it was those types of concepts that I didn't know until I did my BMedSc, because I was just like, oh, look, evidence. And then Megan would be like, but is it the best evidence? And you'd be like, oh, I don't know. And the same thing with looking at controls. You need to really figure out if your controls are appropriate. And then another thing for those who are doing cell work or animal work, a lot of interactions or actions are cell-specific or tissue-specific. So if you're reading somewhere that in prostate cancer, these things happen, but in ovarian cancer, it happens differently, you can sometimes just chalk that up to these actions are tissue-specific, and that's why it's different, as opposed to being well, one of them is wrong, who's wrong? It can't do both things. We all know the difference between in vivo and in vitro. Yeah, so that's really important for a lot of you guys in some science research. And make sure you highlight that so that whenever you read the research, you're really emphasizing this was done in vivo. That makes it, in some ways, a little bit more legit than the research that's done in vitro. And also that concept of downstream versus upstream. I'm sure that some of you guys are way better scientists from the start than I was, but I was like shocking. So even just like knowing that downstream factors will have, like if an article talks about a pathway system, you have to break them into the upstream and the downstream factors and then figure out where your topic fits in. Is it upstream? Is it downstream? Therefore, what regulates it? What does it regulate? And something that I did is that if I was really struggling, I would just read the discussion and not get too bogged down by the methodology and then just see if that answered the question. So with writing up, subsections is the best way to write things up that most people say. It's very important to write in active as opposed to passive. So instead of saying like, you know, it was evaluated, being like we evaluate, oh fuck, that doesn't work. Do you know what I mean? Like there's a difference between active and passive, and I'm blanking out because I'm really tired. But instead of saying like, you know, we did a study on this as opposed to these things were studied. You want to be talking in a very active way because that's apparently meant to be a marker of like good science. Do you have a question? Oh, that's all right. Yeah. Yeah, definitely. And in fact, well, in the literature review, you might not often be saying we because you probably don't have a lot of research to contribute that you've been involved in. But you can say things like my lab hypothesizes or we believe that this is, you know, a prevalent concept. In your discussion and in your thesis, you will be doing that all the time because you're going to be a lot more involved in the evidence process. But in the literature review, you are sort of just critically evaluating what other people have done for most of it. Oh yeah, definitely, yeah. And it's really like you can be a bit more informal than in a super like some like the med assignments and stuff. Like you have to be really formal in those, and you could never do that whole leading someone down the path. But in a literature review, you can say, I'm going to be talking about like, you know, this review will cover X, Y, Z, and then actually go on to cover it in exactly that way. That's completely fine. And then, yeah, filling in paragraphs whenever you can. I was the type of person who wanted to wait till like, you know, everything was perfect and the stars were aligned, and then I would start writing. And it was a terrible idea. Like, start whenever you can. Just write a paragraph. It's going to be super shit, but you can edit it as long as it's done. You'll feel really good about yourself once you start getting paragraphs done. I didn't know that you could disable endnotes. I just used to write like in the author and year and then go back and add it. But Jackie's way of removing instant formatting fixes that, so ignore that. And diagrams. So like the importance of diagrams is just monumental. Genuinely try and have 4 to 5 diagrams in your literature review. And even things that you think can't be a diagram, like I used a diagram to summarize the key things that regulate my protein, which otherwise would have been a really, really boring paragraph, and I just put it in a diagram. And I thought it was a bit of a bullshit diagram, but they loved it. They were like, great use of diagrams. So if you can do anything to avoid writing paragraphs, put it in a diagram. And it's a really nice way to look like you're summarizing things without actually summarizing anything. So yeah, diagrams are the way to go. When you edit, make sure you know when your supervisor's away. There's nothing like finishing your lit review and then they're just like, see ya, I'm gone to the conference. Getting lots of people to read it. So I didn't get many people to read it because Megan was like a very thorough, like sort of supervisor, but lots of my friends have said that getting everyone to read it made such a difference because your mum has a different way of looking at it than your supervisor does. And your mum will get the things that your non-expert examiner are going to be looking out for. So whether or not it's approachable to like the general public. Keep asking yourself, are you making all the criteria? And be like confident to make a critical appraisal of literature. So I used to be really afraid because I didn't think I understood the evidence that I couldn't make a judgment call. but just like do it. Just make a judgment call. And like your supervisor will tell you if you're wrong, but it's good to make judgment calls because it shows that you're being all like critical and evaluating and everything. The limit in a science project, you're probably going to feel like your limitation section makes you feel like the whole project's pointless because scientific BMedScis, by their nature and by the time frame that we're given to do them, can only really chip away at one tiny part of a very complex science process. So don't be sad, that's science. If science was more efficient, people wouldn't like take so long to get things done, if that makes sense. So be comfortable that your project is probably only going to have it fit into a really tiny notch, and use that limitation section to highlight that, because it also makes you look as if you're showing a lot of complex thinking. Back up your end work. All the aesthetic stuff takes a lot longer. They really do like it if you have like a really nicely like laid out lit review and if it looks quite pretty. And use things like page breaks. If you go onto your layout of Word, you can set in page breaks so that there will, like this chapter will always be on a different page, and that way you don't have to like worry about pressing enter to get it onto a next page, and then you add a figure, and then it's like halfway down the page and you're deleting. Is that just me? Okay. Anyways, and final advice. So you may have a shit ton of time. You may have lots of time at the end before your lit review, or you might not have any at all. It just depends on your project. Some people have really tricky lit reviews. Don't worry about it. If you're doing a lab project, this is just my advice. Get in the lab super early. Have a really clear plan of the induction courses. A lot of the times induction courses run like twice a year. So if you miss the first one, you're not good. Know what needs to be ordered. So a lot of these antibodies can take up to 4 months to be ordered. And they're very expensive. I would write down where all the equipment is. You will forget. There are so many freezers and things are always in different boxes. And when it's 2 a.m. on a Saturday, which definitely didn't happen to me last year, and you're trying to find an antibody and there's no one there to help you, you'd be very lucky to have a list. That definitely happened to me. So, and then write down the steps of machine settings, because people will show you how to use very tricky lab equipment and they'll whiz through the machine settings of how to set up things like wells. So just physically write down like clicked file, clicked open, clicked, insert chemical. Because when you're doing it on your own, you might make a mistake, and then that's not great. It's expensive. It's just expensive equipment. And make an experiment timeline. So things are going to go wrong. So give yourself a few weeks for that immuno did not work. Didn't work. And then I need to redo this immuno. And if an immuno takes at least 2 days. So if you think about it, if you're going to have to redo it, you're going to need to put in 2 days for the immuno, 1 day for drying, and then another day for imaging. So that's almost a full week. So give yourself that time and think about how long each experiment takes and therefore how much time you need. And yeah, save your articles for methodology. Methodology is the easiest section of your thesis. You literally just rewrite what other people have written, and there's not a lot of ways that you can rewrite it. So you're not plagiarizing. But it's pretty much the exact same as what someone else has written, and then you can just write that up in July, and then come October, you've already got your methodology ready to go. And yeah, good luck. It's the science ones are harder than the clinical ones, in my opinion. But you end up knowing so much weird stuff that you didn't know at all at the start. With the marks, a lot of people get a bit worked up with the lit review, and then by the time the thesis comes around, no one cares. But with the lit review, remember, it's a communications exercise, and markers will give really random marks. There's so many different examiners in the BMedSci cohort that someone's going to give an 80, someone's going to give a 90, and you can't argue it. There's no point getting upset. You can't really be but I definitely satisfied criteria A, B, and C, because they'll just be that in my opinion, I think it was good. Here's a 70. So just, yeah, don't worry about it. The quality of your research is much more important than the marks, and that's going to be important for the real end game, which we all know is publishing. So when you come to next year and you want to publish your research, no one cares at all if you got a 96. They're going to care if your research was good. And yeah, good luck. It's going to be totally fine. Yeah. Cool.
Thanks, Shag, for that talk. All right, guys. Yeah, if you could thank our two student speakers just once again for giving up their time for coming today. Just before we all go, so yeah, as I said,